Our next topic is maxima and minima. First point, x is equal to alpha is called point of local maxima if f of alpha more than or equals to f of alpha minus h, and as well as f of alpha more than or equals to f of alpha plus h for a small quantity h. That means if you consider the graph like this, alpha is said to be point of local maxima. Let us take this is alpha. This is alpha minus h. This will be alpha plus h. You can observe that this is f of alpha, which is clearly more than f of alpha minus h, and as well as f of alpha plus h. Then x is equal to alpha is called point of local maxima. Okay. Similarly, let us see local minima. X is equal to beta is called point of local minima if f of beta less than or equals to f of beta minus h, and moreover f of beta less than or equals to f of beta plus h. Okay. Graphically, if you consider this is beta, this will be beta minus h, this will be beta plus h. You can see that f of beta less than or equal to beta minus h, and as well as less than or equal to beta plus h f of. So that beta is called as local minima. Okay. Make a note that point of minima, point of minima is same as local minima, same as relative minima or minima. Okay, all these means the same thing. Similarly for maxima also. Okay, next note point, f of beta, f of beta is local minimum value. Local minimum value, f of beta is local minimum value. So if beta is local minima, then f of beta will be its minimum value. X is equal to beta is local minima. Okay. I think it is very clear. Local maximum value of the function need not to be the greatest value of the function. Local maximum value of function need not to be the greatest value of the function. If you see the graph like this, from interval A to D, here you can see, if you consider this is B, at B local maxima you can observe, at C you can observe local minima, at E you can observe local maxima, at F you can observe local minima. Okay, understand? If you consider here whole means at D there is no output. At D I'm considering there is no output. Okay, if you consider like this, then what you can analyze here? Local maxima, local maxima point x equal to local maxima x equal to p x equal to this is e at x is equal to b and at x is equal to e you can observe local maxima exist. Okay, at b and at e. Is there anything for local maximum? Is there anything? There is nothing. So local minima point. What are the local minima points? X equal to A. At A also local minima exists. At A and at C, at F. Okay? Understand? At D, there is no output. At the D, there is no output you can observe. Another note point. For local maxima or minima to exist, function need not to be continuous or differentiable. For local maxima or minima to exist, function need not to be continuous or differentiable. Function need not to be continuous or differentiable. For maxima minima to exist, function need not to be differentiable. Okay, next note point. Maxima or minima points are also called as extreme points. Extreme points are turning points. Maxima minima points are also called as extreme points or turning points. I think it is very clear. Let us take some examples graphically to figure out local maxima and local minima. X is equal to A. What about this? Local maxima or local minima? Local maxima. If I consider the function like this, okay, x is equal to b. What about this? Local maxima. Why? Because you can observe this is f of b. F of b plus is smaller than f of b, and moreover f of b minus also smaller than f of b. That's why it is local maxima. Okay, so what about this? If I consider this is c, what about c? Local maxima. You can observe f of c is this, then f of c plus is smaller, f of c minus also is smaller than f of c. That's why it is local maxima. Then I'm considering this is d. What about d? Then also it is local maxima. Why? Because you can consider if this is f of d plus smaller, f of d minus also smaller than f of d. So it is local maxima. Now, what about this? Yes, local minima. This is point of local minima. What about this? What about this? Is it local maxima or local minimum? Say, for this local maxima, local minima does not exist. Okay, at f. Okay, understand this is going on like this. And moreover, for such type of functions also, take a point A. Local maxima, local minima does not exist at A. Next note point. For a differentiable function f of x at x is equal to a, local maxima exist. Local maxima exist if f dash of a equal to 0, and moreover f dash of a minus should be more than 0 and f dash of a plus should be less than 0. Let me explain about this. Function should be differentiable. At x is equal to a, local maxima should exist. At x is equal to a, local maxima should exist. Okay, then clearly you can see tangent drawn at x is equal to a should be parallel to x-axis. Its slope will be 0. That means f dash of a should be 0. Okay, and moreover f dash of a minus f dash of a minus and f dash of a plus. You can observe function from here to up to a, then first it is increasing, after that it is decreasing. So means f dash of a plus f dash of a plus, you can observe it is decreasing, that's why f dash of a plus should be less than 0. F dash of a minus, you can observe it is increasing. F dash of a minus, whenever f is increasing, f dash of a minus, you can say that it is more than 0. So that's why in the interval a minus alpha to a, function is increasing, then f dash of a minus should be greater than 0. In the interval a to a plus alpha, function is decreasing, then f dash of a plus should be less than 0. Whenever function is decreasing, we know that in monotonicity, its differentiation, whenever it is differentiable, should be less than 0. Whenever function is increasing, its differentiation at the given point should be more than 0. That's it. Next note point. If x is equal to b is point of local minima and f of x is differentiable. F of x is differentiable function. Okay. F of x is differentiable function, and moreover x is equal to b is point of local minima. Then what we can write? F dash of b should be equals to 0, and moreover f dash of b minus should be less than 0, and f dash of b plus should be more than 0. That's it. Okay. Consider the graph for the point of local minima. I'm considering here x is equal to b. You can see f dash of b minus, because it is decreasing, less than 0. F dash of b plus, f dash of b plus, because it is increasing, more than 0. That's it. At b, differentiation will be 0, because at b tangent to the curve is flat, that means parallel to x-axis, its slope will be 0. I think it is very clear. Next note point. Consider f dash of a is equal to 0. Function is differentiable at a, and f dash of a is 0. Then let us discuss about sign of f dash of x. So listen carefully. This is point A. Okay. This is plus, this is minus. That means this is a plus, this is a minus. Okay. Understand? A plus a minus means right hand limit, left hand limit. Like that we can consider. Listen, if right hand limit is f of a plus, that means what about f dash of a plus? I am taking f dash of a plus is positive here. F dash of a minus is positive, and both are negative. This is positive, this is negative, this is negative, this is positive. Then what about this? Local maxima or local minima? Local maxima or local minima? We have to comment. Listen carefully. F dash of a plus is positive, means it is increasing. F dash of a minus is positive, means still increasing. F dash of A plus is negative means decreasing. F dash of A minus is negative means still decreasing. So listen carefully. What about the graph of first situation? So graph may be like this. Okay. F dash of A 0, clearly F dash of A 0 here. So what about F dash of A plus? Increasing. F dash of A minus increasing. This is not a point of local maxima or local minima. Okay. Local maxima, local minima, both does not exist. Understand? What about this? Second situation will be like this. Second situation will be like this. At A, differentiation is 0, but f dash of A minus decreasing. F dash of A plus decreasing. F dash of A minus and F dash of A plus both are decreasing. And F dash of A is 0. In that situation also, local maxima and local minima does not exist. That means we can understand that f dash of A plus into f dash of A minus, whenever f dash of A plus and f dash of A minus both are multiplied, if you get positive, then what we can write? Local maxima, local minima does not exist. Okay, that is the first point. So next point, f dash of A plus into f dash of A minus less than 0, then either point of local maxima or point of local minima exist. Okay, function should be differentiable. Be careful that whenever function is differentiable, then only these conditions will arise. Point of local minima exist. Either this or this, not both. Either this or this. So listen carefully. What about this? First function should be increasing. After that, it is decreasing. Okay? Plus, minus. What about this? Point of local maxima. Local maxima exist. First function should be decreasing. After that, function should be increasing. Fourth case, local minima. That's it. That is the sign of f dash of A plus and f dash of A minus. Whenever f dash of A is 0, listen carefully, these cases will arise whenever f dash of A equals to 0. Then only we have to think about these all. Otherwise, you should not. Sign of f dash of x here. Consider one example problem. Find point of local minima or local maxima for the function y equals to ln x divided by x. First, we need to identify y dash. Denominator x square, numerator 1 minus ln x. U by v formula that you can understand. Okay. First, what we have to take, f dash of something should be equals to 0. So make f y dash equal to 0. Find the points at where differentiation becoming 0. That means x should be e. Whenever x is e, differentiation becomes 0. Now we have to think about sign of f dash of x at right and left of a. A means here particular in the particular problem e it is. Okay, let us do that now. I'm considering E on number line. This is E. At right of E, at left of E, f dash sign we need to identify. Okay. What about the sign? You can see the graph of logarithmic function. And the next graph will be like this. At E, it gives 1. Okay. At more than E, it gives more than 1. Okay. So at more than E, it gives more than 1. Whenever it is more than 1, clearly it is negative. Okay. Here, if I keep negative, then it is nothing but f dash of E plus. Okay. What about f dash of E minus? Here we have to find the sign. Whenever it is less than E, it gives less than 1. It gives clearly less than 1. So whenever if you substitute here less than 1, 1 minus less than 1 will be positive, divided by x square is always positive. So here positive. So first function should be what? Increasing. This is positive means increasing. F dash is positive means increasing. After that it should fall. It should fall means decrease. This is the point at where function becomes 0. This is nothing but point of local maxima. So in this problem, x is equal to E is point of local maxima. I think it is very clear.